Okay. Now, let us get back to our engineering mechanics. So, when I say engineering mechanics, we want to make our life simple. We start with a very simplified assumption, mechanics of rigid bodies. To make our life simple, we idealize, fortunately in this complete course, all bodies as rigid. Okay.
Rigid body is defined as a body in which deformation is negligible or equivalent to zero under the action of applied forces. For example, if a small boy hits a table, the table does not break. In this case, it is a rigid body. Points A and B are the original position in a body. After application of two forces, F1 and F2, the body takes a new position. A' and B' are the new positions of A and B. If the body is treated as rigid, the relative position of A' B' and AB are the same, that is AB is equal to A' B'. In the real world, no object or body is rigid. Many engineering problems can be solved by assuming rigid bodies.
And for aeronautics, mechanical and civil engineers, they will also study mechanics of deformable bodies. Then you also have mechanics of fluids. And if you get into mechanics of rigid bodies, it can be classified into statics and dynamics. And dynamics can be further classified into kinematics as well as kinetics. So, kinematics talks about the motions and kinetics talks about the forces that contribute to this. And if I go to mechanics of deformable bodies, I have strength of materials, theory of elasticity and theory of plasticity. And once you come to mechanics of fluids, we start with an ideal fluid, whereas all fluids have viscosity. Then you talk about viscous fluid, and you also give another assumption, incompressible fluid. That is how you develop the subjects. Okay. Have you been able to write this? Okay.